Hello and welcome back to Global Math Mentor, another lesson on complex numbers. And this lesson, I'll be covering how to solve equations with imaginary roots. So, those who have studied the real number system, you remember, for example, in the quadratic equations, if your discriminant is less than zero, the roots are not real, imaginary, or another word which we are studying right now, we can say the roots are complex. Okay, so I'll be guiding you when real roots exist and when imaginary root exists. What are the conditions behind it? Let's dive into it. All right, let's learn about this useful idea. Use the result that for polynomial equations with real coefficients. So the idea is if an equation, any polynomial equation has real coefficients, any non-real roots occur in conjugate pair. So think about it this way, like for example, if I have any equation, let's say quadratic equation, a cubic equation, or fourth degree equation, what does it mean if the coefficients in equation are real? Take for example this question 1 over here. I've picked an example. In this example, you can see that A is a positive 1, B is a negative 4, and C is positive 8. And you can see that each of them belong to real numbers. They are not imaginary. They do not have a coefficient of iota. So let's find out that do the roots exist in conjugate pairs? Let's go. So first part, I'm going to apply the quadratic formula. Is going to be minus b plus minus a b squared minus a 4a and c, and divide the whole thing by 2a. This will become 4 plus minus a 16 minus a 32 is a root negative 16 and divided by 2. Let me give you a breakdown of how do you evaluate this thing. Now, root negative 16 can be written as root 16 times root negative 1. We know that root negative 1 has a value iota and root 16 is a 4. So that's how you simplify this thing. So my answer is going to look like 4 plus minus a 4 iota divided by 2. Divide the real and the imaginary part with 2 and you'll get 2 plus minus 2 iota. What do you notice? One of the root is 2 minus 2 iota, and the other is a 2 plus 2 iota. So we can see that, yes, that is true. So it's a fundamental result of complex numbers that if the coefficients of any equation, by coefficients we mean the coefficient of x square term, the x term, the constant term, or the cube's coefficient, or the fourth power coefficient, all coefficients, if they are real, roots will exist in conjugate pairs. For investigating this idea on purpose, I have taken the second example where one of the coefficient is not real. Can you notice which one is that? Look at this one. So my B value is not a real number. So A is a positive 1, B is 2 iota, which is an imaginary number, and C is a positive 5. Let's try and solve it and investigate what kind of solutions will we get. X equals to minus B plus minus root of B squared, 2 iota squared, minus 4A and a C. And divide the whole thing by a 2A. Let's see, what do we get? Minus 2 iota plus minus. This is going to be 4 iota square and minus 20. I encourage you all to not just watch these videos, but you can solve these questions side by side with me by just pause the video and go over it. And that way you can practice a lot and that will be beneficial to master this subject. Minus 2 iota plus minus root of, you remember from my first lesson that iota is a square root negative 1, and this is an imaginary number and its square is a negative 1. No real number has a square which is a negative number. Only imaginary number possess this property. So this is going to be minus 4 minus 20, which is a negative 24 over 2. How do you simplify this? Let's try and simplify this thing. It's going to be plus minus. So 24 is like a 6 times 4. So I can write 2 root 6 iota and divided by 2. Well, you can try and see how did I get this thing. Since root 24 in simplified form can be written as 2 root 6 and the negative 1 square root, just like I did over here, you can see that its value becomes iota. So let's divide the real and the imaginary part. Well, you can see that both the coefficients are imaginary this time. So let's see what do we get. It's going to be minus iota plus minus root 6 iota. So one of the answer is going to be minus iota plus root 6 iota or minus iota minus root 6 iota. So it's going to be root 6 minus 1. Both the number, it's just an imaginary number, all of it. And minus 1 minus root 6 iota. So these are my answers. And clearly you can see that these are not conjugate pairs. These are not conjugates of each other. So this will only be valid when the coefficients will be real. And in this case, you can get any sort of roots, but they will not be conjugates of each other. Let's try and solve some cubic equations, and then I'll move on to the reverse cases where one of the roots is given and how do you find the remaining roots. Let's solve this cubic equation. So I'm going to be supposing it p of x, the cubic polynomial, x cubed minus 4x squared plus 6x and minus 4. I do not have any of the roots, so I need to find those by trial and error. So if you multiply the leading coefficient to 1 with a negative 4, you get a negative 4. So what are the possible factors of 4? It's plus minus 1 or plus minus 2 or plus minus 4. So let's try. I know by looking at it, the 1 does not work. So let's try p of 2. It's 2 cubed minus 4 times the 2 squared plus a 6 times the 2 and minus 4. This will give me 8 minus 16 plus 12 and minus 4. So 8 plus 4 is a 20 and negative 16, negative 4 is a negative 20. Bingo. That works. So you can say that x equals to 2 is a root. Okay. So if this is a root, then x minus 2 is a linear factor. Okay. So once you have the linear factor, you can use it to find the quadratic factor by long division. So put x minus 2 outside and let's perform the long division. X cubed minus 4x squared plus 6x and minus 4. Multiply this with x squared. This gives me x cubed minus 2x squared. And you need to subtract the lower expression from the top one. It's going to be minus 2x squared and plus 6x and minus 4. Now multiply with minus 2x. It's going to be minus 2x squared plus 4x. This will give me 2x minus 4. And if you multiply this with 2, you will get 2x minus 4, which will cancel and give you a remainder of 0. So I know that since this is a linear factor, this quotient over here is the quadratic factor. So how do we get all the roots of this equation since I need to solve it? The linear root is, a linear factor gives you a root, which is a real root. Let's see what does the quadratic factor gives me. So x squared minus 2x plus 2 equals to 0. You can calculate the discriminant mentally as well, but let's see, b squared minus 4a and c. Oh, so clearly you can see that it has a discriminant which is less than 0, so it must have two imaginary roots. So minus b plus minus, I've already calculated the discriminant is going to be negative 4 over 2a, which is a 2. So this will give me 2 plus minus 2 iota divided by 2. And divide both sides with 2, both the real part and the imaginary part by 2. This will give me 1 plus minus iota. So the final answer is the real root is 2 and the imaginary roots 1 minus iota and 1 plus iota. And stop and think again. Have you noticed since the coefficients were all real, the roots existed in conjugate pairs? All right. Let's solve this cubic equation where one of the root is given. And also that given root is an imaginary one. Find all the roots. That's the question. Okay, so first of all, you need to identify quickly what is the coefficient of x cubed? That is a 1. The coefficient of x squared is a -6. The coefficient of x is 13. And the constant term is a -10. The reason I'm showing you this is that each of these coefficients are real. So what did we just discussed earlier? That if the coefficients of the equation are all real, then roots exist in conjugate pairs. Very important. Think about it this way that if someone asks you, can a cubic equation have all imaginary roots? What do you think so? The answer is no. Since roots exist, if they are imaginary, they exist in conjugate pairs. I'll show you if you're familiar with the cubic graphs. This is one of the situation with the cubic graph where all roots are real and distinct, right? Y and X. Then this can be another case where one of the root is real and the other is repeated, right? The quadratic factor of the cubic equation will give you a repeated solution. But this is not the scenario that we are discussing right now. One of the root is imaginary. So this must be the case where one of the root is real and rest of the cubic curve is entirely above the x-axis. Since it is above the x-axis, so the other two roots are imaginary, right? I hope you get the idea. So if you're not familiar with cubic curves and graphs and haven't sketched them before, take some time and practice those as well. Okay, so I've got one of the root, which is 2 plus I. So I know that the other root is going to be 2 minus I, the conjugate pair of 2 plus I. I'm looking for another root since I need all the roots, and I know definitely that this root will be a real one. How do you get it? Okay, so learn this way that I'm going to share. How do you get a quadratic factor out of two imaginary roots? So let's get one of the factor. The linear factor is going to be x minus 2 minus iota. And the other one will be x minus 2 plus iota. You get it? So if I multiply the two imaginary factors, obviously I'll get a quadratic factor. It doesn't matter whether they are real factors or imaginary factors, but I'll show you how to get the quadratic polynomial. So multiply, you got to be careful with your algebra. X squared minus 2x plus x iota minus 2x plus 4 minus 2 iota minus x iota plus 2 iota and minus iota square. Oh, hectic calculations, but let's see what do we get. It's going to be, we can cancel the terms which are with opposite signs. So this goes out with this one. And the minus 2 iota and the plus 2 iota cancel each other. So I'm left with x squared minus 4x and 4 plus a 1. Since iota square is a -1, so minus minus 1 will be the plus 1, so a +5. This is a quadratic factor. Okay, let's perform long division. So I'm going to be showing the long division here, x squared minus 4x plus 5, and put the cubic polynomial inside, x cubed minus 6x squared plus 13x and minus 10. So we know from the algebraic long divisions, if you divide by a factor, the quotient is going to be another factor. So let's multiply x squared with x to get an x cubed minus a 4x squared and plus a 5x. Now you need to subtract the lower expression from the top one. So this goes cancel. Minus 2x squared plus 8x and minus 10. Now I need to match this first term. So it's going to be minus 2. And that gives me a minus 2x squared plus 8x, right? Okay, so, oh, a minus 10 as well. There we go. Plus, minus, and a plus. These cancel each other out. So what about this thing? You know that when we divide with a factor, quotient is also, you can say that is the linear factor. Okay? So if I have a linear factor, so the root is going to be one of the real root. This is the real root. And what are the two imaginary roots? 2 minus iota and 2 plus iota. These are all the roots of this cubic polynomial. In this lesson, we learned about how to solve equations with complex roots, and we discussed the idea when the coefficients of an equation are all real, the roots exist in complex conjugate pairs. Stay tuned for more useful mathematical lessons. Over and out.